Welcome, and thank you for joining us for this presentation on the Interstate 94 Midway Grant Marsh Bridge Engineering and Feasibility Study. The key project contacts for this study include Teresa Maas, the consultant project manager with Stantec. Stantec was hired by the North Dakota Department of Transportation to complete the engineering and feasibility study. Michael Johnson is the project manager for the NDDOT. The NDDOT has assembled a Study Advisory Committee, or SAC, which includes representation from the local cities, counties, the MPO, the Federal Highway Administration, and various NDDOT divisions and functional groups. The SAC has been providing a wider perspective throughout the study. In this presentation, we will give an update on the feasibility study, what we've been up to. We'll review the draft preliminary purpose and need, review the range of alternatives under consideration, examine conceptual solutions that will be considered as we move into the alternative stage of the study, and go over what you can expect moving forward. Let's start with the study update. Since our last public meeting in June, we have completed the items approaching the "We Are Here" line. This includes a survey of the study area, both aerial and within the river. In terms of traffic, we calibrated the existing traffic model and performed an existing and future traffic capacity, operations, and safety analysis. We performed environmental scans and early studies, including wetlands, floodplains, Phase 1A cultural resources, and identification of parklands, Section 4F and 6F resources. We met with the local stakeholders to help understand study issues and opportunities. We reviewed geotechnical conditions within the study area. We developed the draft purpose and need statement and developed a range of alternatives for consideration. And finally, we are just starting to look at solutions to some of the roadway issues identified through these early studies and conversations. The study area includes Interstate 94 from the Mandan Avenue interchange to just east of the Tyler Parkway interchange in Bismarck. The study also includes Interstate 194 between I-94 and Memorial Highway and replacement of the Grant Marsh Bridge over the Missouri River. Changes to the interstate system will need to assess and understand impacts to the adjacent interchanges outside of the immediate project location. So the larger study area included within the dashed boundary illustrates the area that helps us understand the impacts that the proposed alternatives may have on area traffic operations and the environment. Goals of this study include identifying existing conditions, resources, and constraints, establishing a preliminary purpose and need, establishing a range of alternatives, and to develop and determine a reasonable set of roadway and bridge alternatives to carry forward into environmental review under the National Environmental Policy Act, or NEPA. In order to develop solutions, we need to be sure that we have clearly identified the problems we are trying to solve, and we know what our desired outcomes are. This is where the project purpose and need comes in. What is purpose and need? And why is it required? The purpose and need provides justification for expending public funds on the project. The purpose and need statement will also be a key factor in determining the range of alternatives and with alternative development and elimination. We will start with the primary purpose components. These are what drive the project. They provide fundamental goals as to why the project is proposed. It's important to note that any alternative that does not achieve every primary purpose will be eliminated as unreasonable. We've also identified other desirable outcomes. These are sometimes referred to as secondary purpose and need components. These are additional goals that are desirable but are not the core purpose of the project. These are opportunities for improvement that may be able to be addressed as part of the project if feasible. An other desirable outcome would not by itself provide a basis for eliminating alternatives in the screening stage, but it could be considered as a factor when selecting alternatives to move forward. The primary purpose for this project consists of 3 goals. Number 1, to provide a long-term interstate highway across the Missouri River, which meets current design standards. Number 2 is to reduce the potential for crashes by providing conforming designs that better meet driver expectations. And number 3, maintain interstate mobility and reliability while extending the congestion-free operating lifespan. We also have 2 other desired outcomes, which include number 1, improve bicycle and pedestrian mobility within the study area by providing new facilities and improving existing facilities. And number 2, seek to minimize impact to the local and regional community by minimizing construction duration and disruption. So essentially, staging the project could inform the build alternatives that are selected to go forward. This project provides an important connection between Bismarck and Mandan, which played into elevating both of these tenets. Now that we have defined the project purpose, let's discuss the need. As you can see on this cross-section of the existing bridge superstructure, the bridge provides a 30-foot roadway section in each direction. Each 30-foot roadway section consists of 2 12-foot wide lanes, which meet current standards, and 2 3-foot wide shoulders, which do not. Typically on the interstate system in North Dakota, bridges provide 10-foot wide shoulders outside and a 6-foot wide shoulder on the inside. The current bridge structure is not feasible to widen. As traffic volumes continue to grow, the bridge will need to be replaced at some point in the relatively near future. The most recent bridge inspection shows condition ratings of fair, which means that all primary components are structurally sound, but repairs and continually ongoing maintenance are required.
This exhibit illustrates that existing I-94 and I-194 freeways and interchanges currently operate acceptable levels of service, which are LOS A through D. However, since the design year of this project is 2050, we need to project how the study area freeways will operate in the future with increasing traffic volumes. This exhibit illustrates that future design year 2050 AM conditions on I-94 would most likely experience unacceptable levels of service, which are level service E or F in both directions. This exhibit illustrates by the extended yellow shaded area that the majority of crashes over the last 5 years, which were rear-end crashes, have occurred on I-94 between I-194 and Tyler Parkway. The crash rate for this segment of I-94, which includes the Grant Marsh Bridge, was higher than the national rate for similar types of freeways. One contributing factor to this high crash rate is the narrow shoulders over the bridge. With the extensive areas of yellow, orange, and red shaded roadways, this exhibit illustrates the magnitude and locations of the crash problems along the study area freeways and intersections. The freeways and intersections shaded in red have crash histories that are more than double the national rates. This study will investigate various mitigation strategies to bring these rates closer to national averages. Due to the restricted width on the existing bridge, bicycles are not allowed on the Grant Marsh Bridge, as they generally are on the interstate in North Dakota. The MPO's Envision 2040 identified the Grant Marsh Bridge as a pedestrian-bicycle gap, with bike and pedestrian trails along both sides of the Grant Marsh Bridge.
Along with the purpose and need tenets, the project alternatives will be developed and reviewed considering other engineering, environmental, social, and economic factors. For example, suitable highway grades or geometric constraints, excessive magnitude of cost, excessive maintenance needs, navigation challenges, aesthetic considerations, Section 4F and Section 6F viability, and other parameters will be considered. The alternative screening process involves reviewing a broad range of alternatives and selecting a more limited number to be carried forward for detailed study in environmental review or NEPA. Looking at this broad range of alternatives starts at a high level, then gets into a progressively more detailed and rigorous screening process. But at the end of the day, any of the alternatives will need to meet the primary purpose and need to continue. We have mentioned the range of alternatives a few times, but what does that mean?
This is a list of potential project implementation options for consideration as the range of alternatives. We have a total of 7 alternative categories that we will investigate. The first option is the no-build alternative. This alternative serves as the baseline to which the other alternatives are compared. It evaluates the outcome if the proposed action is not taken, with allowances for routine maintenance, safety improvements, or other currently planned transportation improvements not related to this study. The second option is the no action alternative. This refers to an alternative developed for which the U.S. Army Corps of Engineers needs to take no action with a federal permit under the Clean Water Act. As the study area includes a crossing of the Missouri River, we will need to determine if a feasible alternative exists that does not require a permit. TDM, Transportation Demand Management, refers to a broad scope of strategies to provide travelers with realistic and accessible alternatives to their existing travel modes and patterns with an objective of reducing traffic volume. They are traditionally applied in metropolitan settings and may include telecommuting, workplace flex time, compressed work week, carpool vanpool incentives, improving bicycle pedestrian facilities, including e-bike users, implementing increasing parking fees, peak period surcharges on parking, tolls, transit, and congestion pricing, which is variable tolls based on traffic levels. TSM, Transportation System Management, is a comprehensive toolbox of solutions which use data and intelligence systems to plan, optimize, and manage various aspects of transportation operations. TSM generally consists of small-scale operational improvements to intersections, signal timing, dynamic message signage, and access management to promote urban area traffic movement more efficiently during daily peak travel periods. Mass transit. The mass transit system's options, when highly utilized, could offer advantages by providing higher capacity than single occupancy vehicles. These systems move a large number of people more efficiently, offering a more environmentally friendly transportation option, especially when operated at peak capacity. BizMan's Transit's current network of existing fixed bus routes operate within Bismarck and Mandan. Fixed routes operate through a predetermined route but do not have specific stations. The Bismarck-Mandan fixed route operates under a flag down the bus system, meaning that a bus can pick up and drop off people at any location within the fixed route that does not lie within a no-stop zone. Improve existing. This option consists of corridor-specific concepts designed to meet the various deficiencies and needs as outlined in the draft purpose and need. Improvements would consider solutions such as reconstructing portions of the existing I-94 Midway system, replacement of the existing Grant Marsh Bridge, and considering a collector-distributor roadway that provides additional lanes along the freeway through lanes to facilitate access with local roadways. Most of the project alternatives will fall into this category. Avoidance concepts. This option involves minimizing impacts to recreational parks, historic cultural tribal resources, trails, and other features that line the Missouri riverbanks in the project area. Several of these attractions enjoy the protection of federal laws and regulations, including transportation laws such as Section 4F under the USDOT or Section 6F regulated under the Land and Water Conservation Act. As with the no action alternative required as part of the U.S. Army Corps of Engineers permit process, any impacts to a 4F or 6F properties will need to consider avoidance alternatives. This could include a crossing of the Missouri River north of the existing route. This could avoid sensitive properties and potentially provide a more direct interstate route, but would also likely result in a longer route for local residents and may require multiple river crossings. Replacing the Grant Marsh Bridge with a tunnel below the river would also avoid the parks along the river, but comparatively higher construction and maintenance costs would be a consideration.
Next, we're going to talk about conceptual solutions. Based on earlier studies and prior feedback, the project team developed a variety of conceptual solutions. A conceptual solution represents a highway or bridge design feature that resolves a specific need at a specific location. Examples might include bridge replacement locations, adding additional lanes or widening shoulders, reconfiguring I-94 or I-194 by eliminating left side exits, shifting ramp locations, improving loop ramp design and allowable speed, or improving connections at Main Street and Mandan. We're going to take a look at 5 conceptual solution zones. The 5 areas are the I-194 interchange, East Main Street, CD roads, the Missouri River crossing, and park avoidance crossings. When the solutions of each zone are combined, they will form an alternative. By choosing various solutions in each zone, different alternatives can be developed. Today, rather than jumping in to develop alternatives, we want to take the time to introduce conceptual solutions within each of the zones that will look to address existing issues present in the corridor. In each zone, we'll review the issues followed by possible solutions. The first zone we're going to look at is the I-194 interchange. The issues present at the interchange consist of the I-94 westbound left-hand exit, which violates unfamiliar drivers' expectations, since most freeway ramps enter and exit on the right side of the freeway in North Dakota. The combination of this left exit and the Tyler Parkway right-hand entrance creates a two-sided weave that requires additional weaving movements. The second issue is a small radius loop ramp, which forces drivers to decelerate to 25 miles per hour to navigate. This is much slower than the typical 50-mile-an-hour ramp and contributes to rollover and run off the road crashes. The next issue is the I-94 westbound left-hand entrance to I-94 westbound. Similar to left exits, this creates disruptions in mainline with faster traffic in the passing lane converging with slower entering traffic. This type of merge is more difficult to navigate since the driver is identifying gaps in mainline traffic on the passenger side of the vehicle. The last issue is the I-194 eastbound two-sided weave between I-94 and Memorial Highway. Traffic from I-94 westbound merges on the left side with I-94 eastbound traffic heading south on I-194 to either Memorial Highway or I-194. This configuration creates a two-sided weave that requires additional weaving movements. The I-94 westbound left-hand exit and small radius loop ramp could be addressed with the following conceptual solutions. By moving the westbound I-94 alongside I-94 eastbound, shown in the green highlights, allows space for an enlarged loop ramp, shown in red. This configuration also allows for a right side exit from I-94. Another possible solution would be creating an I-94 westbound flyover with right side exit. This would remove the left-hand exit and replace the existing loop ramp. Another possible solution would be to provide a dual I-94 westbound flyover. The flyover would service both exits for I-194 eastbound and East Main Street. Now looking at the I-194 eastbound two-sided weave. With an I-94 westbound flyover, Memorial Highway and I-194 connections could be grade separated. The flyover ramp from I-94 westbound to Memorial Highway and I-194 eastbound would drop in between the two ramps from I-94 eastbound, heading to Memorial Highway and I-194 eastbound. So the exit to Memorial Highway is shown in yellow. The exit to I-194 eastbound shown in orange, going on either side of the red flyover ramp. Now to look at I-194 westbound left-hand entrance onto I-94 westbound. This is shown in the magenta line work and would enter I-94 westbound from the right side. Now we'll take a look at the East Main Street zone. The issues present at this location consist of the I-94 westbound left-hand exit to East Main Street, which also violates unfamiliar drivers' expectations. The combination of this left exit and the I-194 left-hand entrance creates a one-sided weave alongside I-94 westbound. The combination of the right-hand entrance from East Main Street and the right exit ramp from I-194 creates a one-sided weave alongside I-94 eastbound. This is a conceptual solution for the East Main Street zone. I-194 westbound traffic would function as it does today, entering I-94 westbound from the left side. However, with this concept, I-94 traffic would exit the interstate to East Main Street on the right side before I-194 traffic enters the interstate, reducing the weaving movement on mainline I-94 westbound. With this concept, the I-94 westbound is located with the I-94 eastbound in the existing interstate median. The I-94 westbound exit can occur on the right side, This eliminates the I-94 westbound weave and left-hand entrance-exit by grade separating the movements and shifting the traffic to the CD roads. The I-94 westbound existing traffic combines with the I-194 westbound traffic on the CD roadway, where the merging can occur rather than on mainline. Looking at East Main Street, eastbound traffic to I-94 and 194 split to two separate ramps after the last traffic signal at Twin City Drive. East Main Street traffic to I-94 eastbound separates from traffic to I-94 eastbound and will merge with the I-94 eastbound ramp to I-194 eastbound. The separation of movements eliminates the I-94 eastbound weave. The next zone we're going to take a look at is the collector distributor roadway, also referred to as CD roads. CD roads run adjacent to mainline freeways and are separated by flush or barrier medians. CD roads are designed to eliminate weaving from mainline freeways by locating the weaving, merging, diverging movements to the less congested CD facility, which improves safety. The CD roads provide access to mainline freeway, but reduce exit and entrance points to decrease disruption in the mainline freeway. Each access point on I-94 creates disruption to the flow of mainline I-94. The flags on this exhibit identify the existing I-94 access points within the study corridor. As CD roads are not common to North Dakota, the next few slides will go into further detail on CD roads. This is an example of a simple collector distributor roadway. The CD roads are shown on the slide in blue and run adjacent to freeways. They have a similar cross-section to divided highways with medians and are designed to eliminate weaving from mainline freeways. This next slide illustrates how local traffic shown with the blue arrows would utilize CD roads between adjacent interchanges and avoid using the freeway mainline lanes. Collector distributor roads would improve traffic operations on mainline by taking the local traffic off of the interstate and shifting it onto less congested connectors between interchanges. They would eliminate weave zones from mainline interstate and would also act as a relief bypass should incidents occur on the interstate. As interstate segments are determined viable for merged zones, various mainline interstate access points can be established from the collector distributor roadway. This concept addresses mainline disruption on I-94 westbound by reducing the number of exits and entrances on mainline by combining destinations. As you can see from the yellow highlight, there's only one entrance ramp to or from mainline in the study area. I-94 westbound will access I-194 and East Main Street by using a single exit onto the CD roadway at Tyler Parkway. Looking at I-94 eastbound mainline, the traffic flow over the river will be improved by eliminating traffic headed to Tyler Parkway and traffic coming from I-194 from mainline I-94 eastbound, as these two movements will be shifted to the CD roadway. Another concept like the previous would address mainline disruption on I-94 westbound by reducing the number of entrances on mainline. I-94 westbound would access I-194 from Tyler Parkway, and East Main Street traffic from Tyler Parkway would combine with I-94 westbound traffic to reduce mainline access points. This concept would add one exit location in both directions of I-94. The I-94 eastbound mainline traffic flow over the river would be improved by eliminating traffic headed to Tyler Parkway and traffic coming from I-194. These movements would shift to the CD roadway. This CD concept would address I-94 eastbound mainline disruption by eliminating weave movements between East Main Street and I-194. I-94 eastbound would access I-194 prior to East Main Street via the CD roadway, eliminating disruptions further downstream in the eastbound direction. Now we'll take a look at the Missouri River crossing zone. First issue present at this location is the crossing. Where should the crossing be located? Second, I-94 westbound two-sided weave. Talked about this earlier with the right-handed entrance from Tyler Parkway and the left-sided exit to I-194. The third issue being I-94 eastbound merge near the bridge. Our next conceptual solution zone is the Missouri River crossings. A new bridge could be reconstructed north or south of the existing I-94 bridge. This concept shows the bridge being reconstructed south of the existing bridge with an I-94 westbound flyover. The flyover would address the two-sided weave by moving the I-194 exit ramp to the right side of the interstate. Another conceptual solution, building off of the previous option with the I-94 westbound flyover, would be to add auxiliary lanes between I-194 and Tyler Parkway to each side of a reconstructed bridge. The addition of the two auxiliary lanes would address both the two-sided weave in the westbound direction and the merge in the eastbound direction. Another possible solution is a CD road option, which would construct 3 bridges over the Missouri River with an I-94 westbound flyover added to the westbound CD bridge. In the eastbound direction, adding the I-194 connection to the CD route would eliminate the merge disruption on eastbound mainline. Our last conceptual solution zone is the park avoidance crossings. With the previous Missouri River crossing zone, there would be impacts to parks that are located on either side of the existing bridge. Federal guidelines require us to look at solutions which would avoid impacting these special properties. To avoid the park impacts, the I-94 corridor would need to be relocated further north. Or another concept would be to tunnel underneath the Missouri River. While these conceptual ideas would avoid the special properties, the concepts would be extremely impactful to other properties in the area and carry a hefty price tag.
Let's walk through the schedule and the next steps for the study. As we have started the alternative development phase of the study, let's walk through the steps involved. The first 3 steps shown, purpose and need, range of alternatives, and conceptual solutions, are what we are asking the public to review right now. Once the comment period is closed, the study team will make any updates to the preliminary purpose and need statement and the range of alternatives. The purpose and need will be used to compare and assess the range of alternatives and to develop a set of alternatives. These alternatives will be built from the conceptual solutions reviewed earlier in the presentation. The project alternatives will be evaluated and screened based on both benefits and impacts. Through this process, the NDDOT will reduce and refine a recommended set of around 3 alternatives within the feasibility study to move forward into programming, funding, and NEPA. Following this public input meeting, we will keep the comment period open until December 22nd. We will then shift into alternative development through next summer and wrap up the feasibility study in late 2024. The study will be published and advertised for review by the public, local government, agencies, tribes, and pertinent stakeholders. If you would like to stay up to date on the project, you can visit the project website, which contains the materials presented here today. There is a place on the website also to subscribe for project updates. You can also email or reach out to either of the project contacts listed. And finally, be sure to look out for our public meeting tentatively scheduled for late 2024. Thank you for joining.